All right, so we are looking at polynomials still in chapter 6. We're going to look at some of their properties with graphs and what happens with them. And we are looking at the degree. Do you remember talking about the degree of a polynomial a couple sections ago? The highest exponent. Okay, so we're going to look at that and also the leading coefficient, so the number in front of that. And it's going to tell us a lot about the graph. Okay, so we are looking at these right here, and we're going to state whether, no, we're just going to say the degree and the leading coefficient. Okay, so on this one, which one are we focusing on? The first, the second, or the third term? Okay, we're always looking at the one with the highest exponent. So what is the degree? And the leading coefficient is 9. Okay, the next one. I would agree, but what's maybe not good about this? Next problem. What's wrong with this? Tell me why that's bad.
Because it's a fraction.
Not because it's a fraction. X is in the denominator, which means the exponent on it started out as what? A negative number. Okay. Up here, written in blue, it says that polynomials have what? Whole number exponents. Okay. So this one's not a polynomial. All right. This one. This third one right here. Look carefully. Someone tell me why this is not a polynomial.
It's negative.
Not because it's negative.
Oh, there's multiple variables.
Yes, there's y's and t's. Okay, so that one's not a polynomial. This one? Is it a polynomial? Yes. Okay, so what's the degree and leading coefficient? Degree is 7. We always pick the one with the highest number. And the leading coefficient is 10. Questions? Yes. Because this right here has a negative exponent. Because it's on the bottom. Any other questions? All right. Looks like we're good on those. All right. End behavior. So we're going to learn about what the ends of these graphs are doing based on that leading coefficient and degree. Okay, so there's 4 different endings on a graph. Okay, we could have them both going up, both going down, or going opposite directions. Okay, so here are some examples. We need to figure out what the common themes are between all of these things. Okay, so looking at, let's just start with the first column where the graphs have arrows that are both pointing up and away from each other. What is in common with the equations that you see? Mainly focusing on the one that determines what the degree is. So this one, there's only one. And then this one, which one would we focus on? This one. What's in common with those? Yep.
There's a 1.
There is a 1 for a coefficient. Okay. What else is in common?
It's always a variable.
There's always a variable, yes. What about the 2 and the 4?
Oh, they're not negative.
They're not negative. Anything else? They're divisible by 2. Okay, let's keep that in mind as we move over here to the next column. These are both facing down. What do we know is in common with these terms? They're both negative coefficients. Anything about the exponents? They're both divisible by 2, or they're both even. Okay. What about this next one where they're pointing in opposite directions? What do you notice besides the fact that they're exactly the same? What's going to be something about these two blue circled ones that's different about the first two columns? The exponent is 3. What could another possible exponent be in that column?
Anything divisible by 3?
Good guess. Not divisible by 3. Odd numbers. So 5, 7, 9. They're going to point in opposite directions. Okay, and then lastly, these ones also point in opposite directions, so it's not surprising that the exponents are odd. But what's in common with them? They're negative. Okay, so looking at this, if you have an even exponent, just like the first two columns, you are going to be facing in the same direction or even to each other. That's one way to remember it. If you have an odd exponent, they're going to face odd directions or opposite directions. And the positive and negative is pretty intuitive on the first two, right? Positive, they're both going up. Negative, they both go down. But over here, an easy way to remember it is if you were to connect these two arrows right here, squish them together, would that line have a positive or a negative slope?
Positive.
A positive slope, which it matches with our positive coefficients. And if you link to these two together to be a line, squish them together, that's a negative slope, and these have negative coefficients. Okay, so those things right there are going to be summarized on this graph right here. So if you scroll down to the next page, they're directly below the graphs that we just talked about. This one's already filled in for us. So if they're both pointing up, that means there's a positive coefficient with an even numbered exponent. So what should we put in this next column? This one has negative coefficient. This one won't be odd because they're both pointing in the same direction. This one's another even one. Okay, now these ones are pointing in opposite directions, these two columns. So what do we know about the exponent for these two? Yes, these ones are going to be the odd ones. Okay, what about the coefficients? What's this one going to be? Think about the slope of this line right here. Yep, so this will be positive coefficient. So this one's the negative coefficient. So we're going to be able to look at an equation of a polynomial and determine which direction the arrows are pointing. Questions on this? Okay, so let's talk about this. Which term are we going to focus on, the first, second, or third? Do you guys have this slide in your notes? Okay. Which one are we looking at? 1, 2, or 3? And why do we pick this one to look at? The 21 is the biggest exponent out of the 3. Okay, so that's why we picked that one. All right, so what is the leading coefficient there? -30. Our degree is 21. So now they want the end behavior, which means we're just going to write what 2 directions the arrows are going to go. So we have our degree. What are we talking about? Positive, negative, even, odd? What are we looking at? What information are we taking from the degree? Not here. The degree, we're looking at odd versus even. Okay, so let's write that right here. Okay, and because it's odd, that tells us what? It's going to be curvy, yes. What do we know about the end behavior, though, if it's odd? Same direction or opposite directions? They're going to go opposite directions if it's an odd number. Okay, that's all we take from the exponent. We don't take positive, negative, because it should be positive. If it's negative, it's not a polynomial. So we look at whether it's odd versus even. It's odd, so we know it's going to be opposite directions. Okay, so they're either going to point this way or this way. The leading coefficient, what are we looking at? What versus what? Yep. What value or what characteristic of this number are we looking at? Odd versus even, positive versus negative?
Positive.
Okay, so we're looking at positive versus negative. And it is positive, or, sorry, it is negative, which means what? These two together. Opposite direction with a negative slope. So imagine that you have a line that's going to have a negative slope like this. So that's the direction you're going to draw your arrows. Okay, and we only look at that highest degree term to figure all of this out. Questions on end behavior? So that's all you're going to be asked to do on the homework. You're going to say the leading coefficient, the degree, and then which direction the arrows are going. There's a second part to the homework, and we're going to go through 2 examples. This first one should be very basic review. I know you've done this in Algebra 1, and we've done it a couple of times this year. But the next one is going to be a lot more difficult. Okay, so but let's just remind ourselves, when they ask you to find d of 2, what do they want us to do? We should all know. Substitute the 2 in for all the x's. Okay, so let's do that. So we've got d of 2. Put the 2 in here, put the 2 in here. And all we have to do is simplify this. Okay, so let's do this in our heads here. We got to do exponents first. So we've got 2 squared, which is 4, times 3, 12, plus, here's 12, minus 10, gives us what? 14? Questions? Okay, so when they ask you to do this, whatever's in the parentheses, we put this item, and it happens to be just a number 2, in for all the x's. We're going to take it up a notch in difficulty and ask, instead of putting in a 2, we're putting in algebraic expressions. Okay, so we're going to take this one step at a time. We also have numbers in front of these that are going to be eventually distributed through our expressions. Okay, so we're going to do, since I underlined these in red, and you may want to use different colors as well to kind of help you keep track, this 6 right here, I'm just going to place on the outside. And then I'll put the 2 over here once we fill all of this in. But let's go back to using blue, and I'm going to use a couple different colors here. So this t right here is telling us what? What is the t asking you to do?
What 6t is?
Yes. So the t being there, does that mean we're using the equation on the left or the equation on the right? Yes, that's just telling you which equation to use to substitute those in. So we know we're looking on the left-hand side because we're using the t of x, but instead of t of x, we're putting in t of 4a. So here's how this works. We've got 4, and in place of here, what are we going to put? Instead of writing x's, we write what? We put this 4a right here. So we put 4a here, we put 4a here. Okay, now this whole thing will eventually be multiplied by that 6 right there. We'll do that at the end. Let's set up the other one as well. So now we have the 2 out front. And now this d right here is saying to use the d of x function, which is over on the right. So I'm going to leave these x's as blank. So we've got 3 plus 6 minus 10. What are we going to put in the parentheses on this one? Right here they told us this is what you're going to substitute in for x. So we've got 3a minus 5, 3a minus 5. Now from here on out, you know how to do all of this stuff. This is just algebra. Okay, order of operations in algebra. So it will take a few minutes and we're going to walk through all of these steps because you're going to get similar problems to this. But know that this is doable for every single person in this room. Okay, it is a long equation, but we can make it through this. So on all of these, let's just remind ourselves of our order of operations. We need to look at all the parentheses first. That means we're going to figure out what's inside of each of the red sets of parentheses. We'll do each of them. Okay. Now inside the parentheses, we need to do exponents first. So let's do that on all of these. So I'm not going to touch a lot of this stuff. We'll just do one thing at a time. We've got 6, we've got 4, but let's use the exponent on this one. What are we going to get if we take the 4 and the a to the third power? We just took our part 1 test on this exact stuff. What is this going to be if we take 4a, the whole thing raised to the third power? So this turns into 64a cubed. Take both of them to the third power. Okay, let's do the exponent here. We've got 5 times what? And then nothing changes here. Okay, now over here, we've got 3. We have to figure out what this is. And that's the only exponent over here. So I'm just going to copy the rest of this down. Now, what do we have to do to figure out what 3a minus 5 squared is? Just square everything in there? We have to do the window. Okay, why do we have to do window on this one but not over here on the left? What's the difference between here and this problem right here? There's a minus in there. So if you have a plus or a minus inside of there, we know we have to do the window step. So I'm just going to jot that down over here. We've got 3a minus 5, 3a minus 5. So it looks like we've got 9a squared minus 15a minus 15a plus 25. We combine these two right here to get what? Negative 30a. So I'm going to write this thing in here. We've got 9a squared minus 30a plus 25. We have no more exponents. We have exponents, but they're not asking us to square anything or cube anything. They're just attached to our terms. So we're done with exponents. We're still working within these parentheses, but now we can do our multiplication and division. We don't have any division, so we're just going to multiply everything that we can. So we're multiplying here, and so on. Okay, so calculators out would help speed this process up a whole bunch. So let's figure out what these all three terms are. We've got 4 times 64. What do we got? Minus. Is it 80? Okay, plus 2. Okay, now we'll do our multiplication on the next one, which is really distributing. Okay, so we'll distribute this 3 right here to all three terms. So now we have 27a squared minus 90a plus 75. And then we'll distribute here plus 18a minus 30 minus 10. So all we did was do our multiplication and distributing. Again, Algebra 1 skills. It looks daunting because it's a really long problem, but you are all capable of doing these steps. What is our next step? What would be a good idea to do over here on the right to kind of clean things up? Yeah, let's combine like terms. Where are our like terms? Looks like we've got these two we can put together, and then all of our constants can be put together. So let's clean this up. This won't change. We've got 27a squared. How many a's do we have now? 72. And what's our number? Okay. What's next? What would you do on the test if this was in front of you? Yes, we would distribute now these numbers out front to everything inside. So help me out with these bigger numbers, please. What's the first one? How much? Okay, and then we have minus 480. Plus 12. And we've got 54 and 144 and 70. Are we done? One step left, right? What is it? Combine like terms. So let's look for those like terms. Nothing matches with the cubed, but we can put this one and this one together. And it looks like this one and that one together. Is that it? Okay, so we've got 15, 36, a cubed. How many a squareds do we have now? Negative 4, 26. We have minus 144a. And we have 82. Now, is your test question going to be this long? No. Okay, the reason I went through such a large problem is to go through every single possible scenario that you would have, but your problems will be about half this size. But I wanted to give you an example where you would have to use the window, where you're going to have to combine like terms, or you have to distribute. Okay, the hardest part for kids is this first step is just writing it down. The thing you need to realize and remember is whatever's in the parentheses, that's what you're just dropping in place for x. If there's a number out front, you put a number out front. So there was a 6 here, we put a 6 here. So if you need help on that first step, please ask so that you don't do the whole problem wrong because you did your first step wrong. Okay, any questions?